Okay, so let's start refactoring this. That's a fancy term for revising it. So that we use an array list so we can have lots and lots of objects. Right now we've got 5 ball objects, and then inside setup we run the constructor 5 times to create each new object with a different set of values. They all start off in the same place with the same XY coordinate, but they've all got different speeds and some different sizes. Then inside draw, there's 2 main things that we need to do with every object. We need to draw it using the ellipse command, and we need to update its position. So here, I've grouped it so that we draw all 5 objects first, and then we update all 5 objects. So here we're drawing an ellipse at the location of bxy, then at ball 2xy, then at ball 3xy, and so on. Okay, so let's run it just to verify that it works before we change it. So you can see all the objects bouncing around now. Very nice. Okay, so let's change it so that we have an array list instead. So instead of ball, we'll say array list of ball objects. And remember, if we wanted this to be like a list of names, we would say array list string. And if we wanted it to be a list of numbers, we would say array list integer. So ball here in the triangle brackets is just saying that the variables that we want our list to contain are all ball variables. So we've got ball list. I'm going to hit Alt Enter to import the class. All right, so now we've got this variable that could hold an array list, but we haven't actually made one yet. So inside setup, the first thing we're going to do is say ball list equals new array list. So notice usually we do these 2 things in one line. We say array list ball list equals new array list. Here I've split it into 2 parts. I'm saying array list ball list, so that's declaring the name of the variable. And then I have that same variable and I'm assigning it the empty list. And remember, this is the constructor that will make an empty list. So now instead of creating a whole bunch of separate objects like this and saving each into its own variable, I want to add each one to its own list. Sorry, I want to add each one to the ball list. So instead of saying b equals, I'm going to say ball list.add, and then I'm going to have this ball inside the parentheses. So look just at this one line. If I put my cursor here where the opening parenthesis is, you can see the matching closing parenthesis. So if I highlight what's inside, this is the full constructor that creates an actual new ball object. So this part in blue is creating the ball object, and then I'm adding it to the ball list. So that's what I want to do for the next 5. So if you want to speed up the video, feel free. Otherwise, I'll just be typing here. I'm going to do it this way. Oops. Yikes. I tried to get clever and do this in a faster way, but it turned out just to be slow. Okay, there we go. So you can see it's got the same pattern. Here, I'll try and line up the spacing so that you can see. The computer doesn't care about the spacing. This is just to make it easy for us humans to tell what's happening. So you can see I'm adding 5 things to the ball list, and each thing that I'm adding is a new ball object that's been constructed with the constructor. So this does the exact same thing as before, only now all of our objects are in the list instead of in their own separate variables. So what that means is that instead of having 5 lines where I draw it and 5 lines where I update, I can loop over every single location in the list. So I can say location starts at 0. Let's make location less than balllist.size. Because right now balllist.size is 5, and so I want my location to go to the very, very end. So this is a way of saying, like, start at the first location, 0, and keep going as long as my location is smaller than the end. Oops. All right. And so then what I want to do is I want to get the ball object located at that location. So if I wanted to get the first ball, I'd say get 0. If I want to get the next ball, I'd say get 1, and then get 2, and then so on. But the lock variable is a variable that goes through all those numbers. So the first time I go through this loop, lock is 0, so I'll be saying get 0. And then the next time through the loop, lock is 1, so I'll be saying get 1. So if you want to know which ball is ball B, the answer is all of them. It just depends on which repeat you're on. The first repeat, ball B, is actually the first ball on the list, and then the next repeat, ball B, is the next one. So because the variable B contains each ball in the list one at a time, that means that I can just do each of these commands once. If I say draw ball B, this is going to loop 5 times, and so we're going to draw an ellipse 5 times, once for each ball. And so that means we don't have to have all 5 of these. Same thing for update position. We're going to loop 5 times, so we're going to tell B to update the position 5 times. But each loop, B is a different ball because I'm assigning it a different ball from the list. So now this code does the same thing. It's just that I didn't have to list each of the balls separately. I can just loop over every single location, get the ball at that location, and then tell the ball at that location to do all the things that I want it to do. All right, so I think we're at a point now where we can run it, and it should be the same. Okay, so it's the same. So now is when it gets really exciting. Here I was adding each new ball separately. Let's make a loop for this also. Except this time I'm going to loop my loop 5 times. So just I less than 5. It wouldn't make any sense to say balllist.size here because on line 15 we haven't actually added anything to the list yet because we just created it. So on line 15, balllist.size is 0, so it wouldn't make any sense to loop from 0 up to 0. So the purpose of this loop is not to loop over all of the objects that are already in the list. The purpose of this loop is going to be to add objects to the list. So I'm going to create a temporary object. I'm going to create a temporary object that's a ball object, where I'm going to run the ball constructor. I'm going to start it at 300, 300, but then I want to give it maybe a random x and a random y for the x and y speeds. So I'm going to make an int called x speed, and it's going to be math.random times 10, but then I'm going to subtract 5. So this should be between -5 and +5. And let's do the same thing with y. So now I can initialize this when I run the ball constructor. I'm going to get, so this is looping 5 times. Every single time I loop, I run the constructor. I'm giving it the same starting coordinates every time, but every time I go through the loop, I'm generating a new random number for the x speed and the y speed. And then let's make the sizes always be 30. So this is looping 5 times. I'm creating 5 ball objects, but I want to add all of them to the list. So here I went back to, rather than running the constructor directly inside add, here I've run the constructor on its own line, saved the object into a temporary variable, and then I'm saying add the ball inside that variable to the end of my list. So now I've got 5 ball objects, but now they're all random. Let's run it and see. Okay, so far so good. But now here's the magic. If we were to make this 50 instead of 5, now I'm looping 50 times, and so it's going to create 50 objects. And we're adding each object to the list. So now my list should be 50 objects long. And that's where I create it. What happens down in draw? Down inside draw, I'm still looping over every single object in the list, only now there's 50 of them. And I get each object out, and I tell each one, let's draw an ellipse where you are, and let's update your position. So I'm still doing the same things I used to be doing, only now this same code works for all 50 all at the same time, because of this powerful idea that we can get each ball from the list one at a time and then tell that particular ball to do its thing. All right, here we go. Oh yeah. So you might notice it forms this wonderful pattern. The reason why it's forming this wonderful pattern is because all of our speeds are integers. In the problem set, I ask you to change all of the speeds to be float. Let me just show you what that looks like. So here, instead of int, if we make this float, float is just like double. It's a data type that represents a number with decimal places. Only float is, you can't make these double because our graphing package doesn't like doubles. It doesn't support them. So we're going to make everything float. You may need to make a couple of changes here. So you'll need to change all the ints to be floats. So wherever you see an int, make it float. I just copied and pasted here. Same, let's make the diameter be a float also. Everything's going to float. Okay, so I think that's maybe it. For set random speeds, you probably want float now. For set random position, let's make it float. Float, float, float. Everything's float. Okay, great. So now that we've done that, back in main, x speed and y speed can all be float. So with this, all right, so now what have we done? We've made it so that the speeds don't have to be like -5, -4, -3. We could have a speed that was like -3.2 or, like 2.8. So that means that when we make our 50 objects, they're really going to appear much more random. There we go. And like, why stop at 50? 500. Let's make them smaller though. I'm going to make 500 objects, and remember this last number was the diameter. That was from the homework. So let's make them diameter 5. Cool. All right, I hope that this was enlightening. Good luck on the problem set.